Over the past few years, AI has been in the news almost non-stop, but more recently, the focus has changed. The talk around AI has become more focused around a specific type, generative AI. So what is this and how does it differ from the AI we've been hearing about? Well, in this video, we'll explain all, and perhaps more importantly, what impacts it has on model development, hardware requirements, and the skill sets needed. Traditional AI systems are primarily used to classify data, make recommendations and predictions, whilst generative AI goes a step further by creating new data similar to its training data. In other words, traditional AI excels at data analysis, whilst generative AI excels at pattern creation. The created content could be text, images, video, music, or even a combination of these. It's generated by AI algorithms that analyze patterns in existing data sets to mimic style or structure, and when prompted with keywords, produces novel content in a similar fashion, the most famous generative AI model being ChatGPT. You're most likely aware that AI always requires massive amounts of data to train a model, as the more examples of what your model's focused on offers the widest reference points and will therefore result in the most accurate model. If an AI model is to recognize animals, then an algorithm trained on a few hundred images is likely to struggle at identification, as it's only been exposed to a limited number of features and characteristics. If tens of millions of images are used to train it, the resulting model will be much more successful. If a generative AI model is tasked with producing pictures of cats, you can imagine it needs a much larger data set. It may only take a few attributes to recognize a cat, face shape, whiskers, or pointy ears, for example, but it will require maybe 50 to 100 attributes to accurately draw a cat. And it's for this reason these generative AI datasets are often referred to as large language models, or LLMs. Now, although there are no hard and fast definitions, the term large in this case usually refers to datasets with over 1 billion parameters, as opposed to the tens of millions that make a good predictive AI model. And it's not just the size of dataset that sets LLMs apart. The training of an LLM has multiple steps, usually starting with an unsupervised learning approach where the model is trained on unstructured and unlabeled data. The benefit of this is that there's often vastly more data of this type available, and although untreated, the model begins to derive relationships between different words and concepts. The next step is training and fine-tuning with a form of self-supervised learning. Here, some data labeling has occurred, assisting the model to more accurately identify different concepts. Next, the large language model undertakes deep learning as it goes through the transformer neural network process. The transformer architecture enables the LLM to understand and recognize the relationships and connections between words and concepts using a self-attention mechanism. That mechanism is able to assign a score or weight to an item in order to determine the relationship. And it's this advanced phase that creates the complex relationship that characterizes an LLM and makes it possible to prompt it to generate new data, hence the term generative AI. Now we understand the mechanisms behind LLM and generative AI. It's perhaps no surprise that developing and training such models relies on far greater compute power than your average AI project, not least due to the considerable memory required and the enhanced parallelism necessary for a higher number of CUDA and Tensor GPU cores. With that in mind, it's only the most powerful GPU-accelerated training servers that can address these factors and effectively create LLMs. In fact, it's the vast resource required for generative AI that's the root cause of the current shortage of data center GPUs. As an NVIDIA Elite partner, the Scan AI team has been working alongside our 3XS Systems division to develop hardware configurations aimed at generative AI solutions, including the world's first 6 GPU workstation, requiring no data center infrastructure usually needed for this level of compute power. It features water cooling to keep noise and heat to a minimum, so it can take a variety of NVIDIA GPUs. Solutions for training LLMs include clusters of NVIDIA DGX appliances, plus custom-built EGX and HGX servers, all offering greater system memory and advanced connectivity. Taking things even further is the DGX GH200, specifically designed to power generative AI. At the heart of the DGX GH200 is the Grace Hopper Superchip. These combine an NVIDIA Grace CPU featuring 72 ARM Neoverse cores with 480GB of LPDDR5 memory, with a Hopper H100 GPU with 96GB of advanced HBM3E memory. The two chips are connected with a high bandwidth, low latency, memory coherent NVIDIA NVLink chip-to-chip or C2C interconnect. The DGX GH200 is essentially a cluster of DGX servers based around the CPU-GPU combined superchip. It features 256 GH200 superchips linked by the NVIDIA NV-switch system to form a two-level non-blocking fabric to fully connect the Grace Hopper superchips. So each GPU in a DGX GH200 can access the memory of all other GPUs and extended GPU memory of all NVIDIA Grace CPUs at an astonishing 900 gigabits per second. Every Grace Hopper superchip in a DGX GH200 system is paired with one NVIDIA Connect X7 network adapter and one BlueField-3 DPU. For scaling beyond 256 GPUs, Connect X7 adapters can interconnect multiple DGX GH200 systems to scale into an even larger solution. With so much investment and technology evolution aimed at LLMs and generative AI, we think it's fair to say that it does seem here to stay. If you're thinking about deploying generative AI in your business, then the Scan AI team can advise you on the best solutions. Our contact details are on the end screen and in the description below. Drop us your thoughts in the comments and don't forget to subscribe to the Scan AI channel so that you never miss the latest goings on in this ever-developing industry.